Another method for solving quadratics is our quadratic formula. Quadratic formula should, I hope, for most of you, be something that you've seen before and is somewhat familiar, okay? We've gone through factoring. We've gone through completing the square. We've gone through square root property, which we use also when we're completing the square. This is our last method for solving quadratics, is the quadratic formula, okay? It is kind of the last-ditch effort. A lot of people think of it as the easiest way to solve, but in all honesty, for sometimes it is, it lends itself to a lot of easy math errors, so you need to be diligent about doing the calculations correctly, okay? It can be the easiest. It will always work when we're trying to solve, but you have to be careful because it's easy to make some simple arithmetic errors. All right? It also requires you to memorize the formula. I am not giving it to you. You need to have it memorized. Okay? X is equal to negative b plus or minus the square root of b squared minus 4ac over 2 times a. Okay? That's the quadratic formula. If you do not already have that memorized, my advice to you is every single time that you use the quadratic formula, write down the formula for every single question. Don't just fill it in. Write down the formula. Write it down over and over and over and over and over. And when you're home, alone, or in your dorm by yourself, say it out loud while you write it. So you sound like a crazy person, but it helps you memorize it. Okay? And then eventually, you'll know that x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. You'll have it like that. So say it to yourself over and over and over and over and over. And that's how you're going to memorize it. Okay? So the quadratic formula is derived by completing the square, but with our generic standard equation of a quadratic. Okay? We complete the square with a quadratic, and then we end up getting the quadratic formula. Notice how it looks very similar to a lot of the uglier answers that we get with quadratics, okay? Because they come from the same thing when we're completing the square. When we use the quadratic formula, the most important thing to remember is that the equation must be in standard form. It has to be in standard form. If it's not, well, then you're going to have the wrong signs, and then you're going to get the wrong values, and it's going to screw up the whole process. Okay, so if you have anything on the other side of your equation, if it's not set equal to 0, you need to get your equation set equal to 0 first, and then it's just a matter of plugging it in and simplifying. Okay, plugging it in and simplifying. All right, so the first thing is my equation set equal to 0? No. How do I get it set equal to 0? Subtract by 1. So I get 11n squared minus 9n minus 1 equals 0. Now, your values for a, b, and c are just your coefficients and your constants. I don't ever want to see a variable inside your quadratic formula. Okay? You will never put an x or a y or a p or a q, nothing, inside the quadratic formula. It's just the numbers. Coefficients and constants only. Okay? So, looking at our quadratic in standard form, what's the value of A? 11. What's the value of B? Negative 9. What's the value of C? Negative 1. So we're going to plug that into our formula. X is equal to negative B plus or minus the square root of B squared minus 4AC all over 2A. Okay? Write out the formula every time you use it so that you have it memorized. Just plug it in. All right? So I've got negative 9. B is negative 9. Plus or minus the square root of negative 9 squared minus 4 times 11 times negative 1 all over 2 times 11. Couple things that I want to highlight and note. 1, pay attention to this. You'll always get a sign switch on B for the start. Secondly, if you put that into your calculator wrong, you're going to get the wrong answer. Okay? Whenever I square something, whether it's positive or negative, my answer is always going to be what? Positive. So if you plug that into your calculator and you square it and you get negative 81, put it in wrong. You should always get a positive there, okay? Because we're squaring it. So negative 9 times negative 9 is positive 81. Now, that's why I put that in parentheses. If you put it in parentheses and then square it, you're always going to get the right value. Now, do not try to evaluate this all in one go. Do it in chunks, okay? I always start with the radical. That's my favorite way to start, okay? I want to get that knocked out. And we're going to talk a little bit more later about the importance of that radicand. And so I always like to start with that, but some of this stuff is also easy to do. When we do the sign switch, we can multiply. This stuff is what it is. But don't go too fast, okay? So when I'm trying to simplify the radical, first I'm going to do my square. What's negative 9 squared? 81, okay? And then I'm going to take 4 times 11 times negative 1. What does that equal? It's going to end up being positive 44 because I've got negative 4 plus times 11 times negative 1. So I get plus 44, okay? Do that part first because a lot of times you'll make a mistake if you do the whole thing all at once. It's really easy to do it. I see it 1,000 times. I've been doing this for a long time. I've taught Algebra 1 through pre-calculus for the last 6 years, and the most mistakes I see with quadratic formula are the math in there. Okay? Do it in one go and you mess it up and you don't catch us. Okay? Especially if you forget to put that in parentheses and you square it and you don't see it if you don't do it in 2 separate steps. Okay? Now on the outside, if I have negative 9, what does that equal? Positive 9. And then 2 times 11. 22. Okay, so we got one step of simplifying it. We were able to simplify a few things at the same time. All right, now we can go ahead and add 81 plus 44. 125. So I end up getting 9 plus or minus the square root of 125 over 22. Now, can I simplify and or square root 125? Okay, by what? 5 times 25, so 9 plus or minus square root of 25 times 5 over 22. What's the square root of 25? 5. So plus or minus 5 square root of 5 over 22. Yay, we did it. That's it. The only other thing you have to check for is if all 3 of these numbers have a common factor, then you can divide by that common factor. But it has to be all 3 of those numbers. The coefficient on the radical, the constant being added to the radical, and the denominator. All 3 of those numbers have to have a common factor in order to simplify. Otherwise, you leave it as it is. Okay? You're not going to do anything else with the radical. We've already simplified it. Doesn't matter if it has a common factor with anything else. Okay? Questions so far? It's real straightforward. The hard part is you got to know the formula. Alright? Now, I have a quadratic, but I have these ugly fractions. Does anyone remember what we do to get rid of fractions when we want to solve an equation? Hint, it has something to do with the LCD. Well, we can find the least common denominator, but didn't do something with it. So I don't actually want to keep fractions. Fractions are really awful to work with. So I need to know what the least common denominator is, but I don't want to change all of those to a common denominator. No one remembers. What is my least common denominator? 8. Multiply everything by your least common denominator. What's 1/8 times 8? What is 8 times 1? What's 8 times 5 halves? Now I don't have fractions anymore. Now I can use my quadratic formula. What's my A value? What's the B value? What's the C value? There you go. Quadratic formula. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. It's a really hard time doing that without seeing the negative 8 plus or minus square root. Actually, you do. You plug it in. What's that? Plug it in, solve. Give you 2 minutes.
Why are we multiplying AC by 4?
Ask me later and we'll derive the quadratic formula. See where it shows up. Alright, 8 squared. -64. Negative 4 times 1 times negative 20. And 2. 64 plus 80. Can I square root 144? Okay, so then you need to do both plus and minus. You have to do both of those. So negative 8 plus 12 over 2, negative 8 minus 12 over 2. Negative 8 plus 12 over 2, x equals, and x equals negative 8 minus 12 over 2. What's negative 8 plus 12? 4 divided by 2. 2. So x equals 2. And then negative 8 minus 12 divided by 2. So we got our two answers, 2 and negative 10. Alright. Is my equation set equal to 0? Nope. So how do I fix it? Okay. Am I in standard form? No. So how do I fix it? Say again? Yeah. We'll go ahead and distribute that x. Am I in standard form now? Yeah. So what's A? What's B? What's C? What's my quadratic formula?
6
can check. Negative 6 plus or minus 6 squared. 6 squared. Negative 4 times 1 times 30. $36 minus 120. It is a negative number. I would like to know which one. Okay. Can I square root negative 84? I'm going to get I, but can I square root 84? No. Can I simplify it? Probably. 5/4. So I've got negative 6 plus or minus square root of negative 1 and 4 and 21. Right? So I can square root 2 I root 21 over 2. Does negative 6, 2, and 2 have a common factor? 2. So I can divide all of those. That is a highlighter. Let's not use that to show subtraction. I can divide all 3 of those by 2. Notice how I'm not touching the 21. Leave 21 alone. It's already done its job. Negative 3 plus or minus 1i, or just I. And then 2 divided by 2 is 1. I don't need that denominator of 1. And then we're done. We got it simplified. So, all of these methods have their different uses. Okay? We started with factoring. Factoring is the most ubiquitous. If something can be factored, generally factoring will be the fastest, the easiest, and the most reliable method. So you want to be able to check, can something be factored? We also have a way of using the quadratic formula to check if something can be factored. Square root property is actually probably the easiest way to solve, but it requires your quadratic to be in a very specific form, which is why we have the process of completing the square. So completing the square and quadratic formula are 2 methods that are used when we cannot factor a quadratic. That's what they're for. Now, quadratic formula is often easier than completing the square. However, completing the square is something that we're going to be using more in chapter 11 because there's a lot of information that we get by completing the square, okay, that we use specifically with graphs of quadratics. So we need to be able to complete the square so that we can do graphs of quadratics. If I'm just caring about the solution, then quadratic formula is fine. But I want to emphasize this point really clearly because it happens every single year. On your assessments, it will say specifically what method to solve. It'll say solve by using quadratic formula. Solve by completing the square. Any problem can be solved using either method. Okay? But when I ask you specifically, solve by completing the square, if you don't, I don't care if you got the right answer or not, I'm giving you 0 credit for that question because you did not do what the question asked for. Solve by completing the square. Solve by using quadratic formula. You have to use the method specified. If it does not specify, then you're free to do whatever you want. You can factor it, you can use quadratic formula, you can square, you can use square root property. You need to make sure you read the directions so that you're doing whatever method is being specified. There is a method to the madness, and I need to assess that. Okay? Now, we have part of our quadratic that's called the discriminant. It's the radicand, the expression under the radical sign. So b squared minus 4ac is the discriminant. And the discriminant is this magical property, okay, that will take on a value that is either positive, 0, or negative. That's what we're looking for. Is the discriminant positive? Is the discriminant negative? Or is the discriminant 0? And based on that information, The discriminant will tell us how many and what type of solutions we'll get. Because we got all types of different answers. We got pairs of whole numbers. We got irrational numbers like plus or minus the square root of 3. Okay? We also got imaginary numbers. We got all types of different answers. Those are all irrational. We even got fractions like 5 halves and 1 half. Okay? We get all different types of answers. The discriminant will tell us what type of answer we're going to get. Okay? Whether it's going to be 2 distinct real solutions, 1 real solution, or no real solutions. Okay? Meaning 2 non-real solutions. It also tells if it's going to be rational or irrational. We won't go that far in depth. Okay? And so here's what we're looking for. Okay? So let me go back. If our discriminant is positive, we're going to have 2 real solutions. If our discriminant is 0, we're going to have 1 real solution. And if our discriminant is negative, we're going to have 2 non-real solutions. So 2 real solutions would be something like this, something like this, something like this. Those are all real solutions. 2 non-real solutions, that would be something like this. And a 1 real solution, you'll find that you don't have the plus or minus because you just get the square root of 0 with 0, and then you just have the number that's left over. So we want to use the discriminant. And again, I want to emphasize this. It says to use the discriminant. That means all I want to see, erase for me, please. That should have way too big. All I want to see is b squared minus 4ac. You plug in the values and you solve. I don't want to know what x equals. Do not solve for x. Don't do it. Don't do it. Because you're going to lose points. Don't solve for x. First of all, you're doing more work than you need to, which is kind of ridiculous. Good question. You're like, oh, it's actually less work. This is easier. Do fewer things. Okay? Do not solve for x. I don't care what x is. It just says use the discriminant to determine the number and type of solutions. So all I'm using is b squared minus 4ac. What's my value of b? -7. So -7 squared minus 4 times, what's my value of a? 1. What's my value of c? 6. Okay? -7 squared. What's -4 times 1 times 6? What's 49 minus 24? 25. Okay? Is that positive, 0, or negative? Positive. Since it's positive, that means I'm going to have 2 real solutions. And taking it even a step further, can I square root 25?
Yes.
Because I can do that, it means I'm also going to have 2 rational solutions. Remember, rational numbers are also part of a subset of real. So I will have 2 real rational solutions. Okay? If it's something that I can't square root, well, then my solution is going to be irrational. Alright? Now, same thing. B squared minus 4ac. What's my value of b for the second one? What's my value of a? 12. Notice on the squared term. What's my value of c? 5. -4 times 12 times 5. 5 is not a.
How did you get 5?
Is this in standard form? Put it in standard form. A is 12. -4 times 4, -4 times 12 times 5. What's 4 minus 240?
Aren't you supposed to square that?
I am supposed to. Thank you. 16. 16 minus 240. So am I going to have 2 real solutions, 1 real solution, or 2 non-real solutions? 2 non-reals, because it's negative. 2 non-real. Okay? Standard form? Are we in standard form? Okay, so we're good. So what is B? Negative 6 squared minus 4 times, what's A? 1. What's C? Okay. Negative 6 squared. Okay. Negative 4 times 1 times 9. Okay. That equals 0. So how many solutions? 1 real solution. 1 real solution. Okay. So let me highlight some stuff. Alright. So determine the number. That's a number, that's a number, that's a number. Determine the number, it's either going to be 1 or 2, of solutions. And determine the type. Real, non-real. Those are your 2 options. Real or non-real. Okay? This is what it all comes down to. So we've got this chart. If my discriminant is positive, 2 real solutions. If my discriminant is 0, I've got 1 real solution. If my discriminant is negative, it's 2 complex, but non-real solutions. Okay? Non-real solutions. This ties into when we're going to be graphing within our next unit. Okay? What it means to have 2 real solutions is that I have 2 x-intercepts on my graph. When I have 1 real solution, that means my vertex is my x-intercept that only crosses the x-axis 1 time. At the vertex, I have 1 real solution. And when I have 2 non-real solutions, notice that there's no x-intercept. So that's going to be something that we use very heavily in our next unit because we're going to be graphing our quadratics, and it's an easy way to determine some of the key information very, very quickly. We will use our we'll complete the square to find the vertex of our quadratic. We'll use it to determine which direction it's going to go. We can look at the discriminant to tell whether or not we're going to have intercepts or not. We're using all of these tools to be able to graph our quadratics. So we have to kind of have all of those in our toolbox in order to be successful with that. Okay? So that's that.